Alright folks, so what we're looking at today is Visual Studio 2012 SSDT or SQL Server Development Tools, also known as database projects, and what used to be called or nicknamed as Data Dude in older versions of Studio. What this gives us is the ability to source control our database schemas, also full-featured IDE with IntelliSense, debugger, and whatnot. Design time error checking. So essentially, as you're typing the script, your SQL script, it will tell you if there are any errors. Also, you can compile and make sure that your script is actually fine. Refactoring database objects. So, for example, I can rename a table and it will automatically fix all the references for me, including all the foreign keys and all the stored procedures and whatnot. Automatic deployment script generation. So once we've made all the changes, once we are happy with it, it will automatically generate all the scripts for us to deploy to a production database. Schema comparison. So essentially, we can compare two schemas, whether they be two point-in-time snapshot schemas, or we're comparing a live database against our scripts and whatnot. This is pretty cool, so let's take a look. All right, so I have my instance of Studio 2012 running. I'm going to go to the View menu, select SQL Server Object Explorer, and this brings up the Object Explorer. I'm going to right-click, say Add SQL Server, and this will connect me to my local instance of SQL Server 2008 running. As you can see here, I have an AdventureWorks database, which is a Microsoft sample database, and it has various tables in different schemas and views and stored procedures and whatnot. So I'm going to right click on this and say create new project. So I have a live database and I'm creating a project out of it. I'm going to select all the defaults here and click on the start button. And this will essentially go and reverse engineer my entire database, which is pretty cool. So as you can see, it's generating all the keys and tables and stored procedures and all the database objects essentially. Once it's done, which takes a little while, click on finish, and on this window right here, I can see my entire database schema. So if I click on, by the way, this schema is organized by schema name. So this is the DBO schema, this is the human resources, person, production, whatnot. So let's look at the production schema. There are certain tables in it. If I click on a particular table, it should bring up the table designer, which is pretty neat, and also the script. So here's the table designer. Here's what it looks like. It's basically same thing as you're used to in SQL Management Studio. Also, the script that you see here, it is synchronized with the table designer. So whatever changes you make to the script will appear in the designer, and whatever changes that you make to the designer will also appear in the script. All right, so the first thing that we're going to do here is right click on our project, click on properties, and this brings up my project properties that you're familiar with pretty much in the context of regular C# or VB.NET projects, but it's a little bit different in the context of SSDT. What you see right here is the target platform being set to SQL Server 2008 automatically. This is because we reversed engineered our database, which is a SQL Server 2008 database. But we have the option to target any SQL Server version starting 2005 all the way up to 2012, and also SQL Azure. SQL CLR, if you have any assemblies that run within the context of SQL Server, this is the information for that, what version of .NET Framework and whatnot. build, essentially, this is your build output path. What you see here is treat transact SQL warnings as errors. I almost always check this box if it's not already checked. This is because when there are some warnings in SQL Server, they're essentially indicating some sort of a fault, some sort of an error that would cause issues later on. So I almost always check this box and make sure that those warnings show up as errors when I compile my script. Here you can also suppress certain SQL Server warnings. So there are some warnings that you know about and you consciously make a decision that I don't want those warnings to be treated as errors. You can list those warnings here. Command variables. Essentially, these are variables that will be available to you during your deployment scripts. So Visual Studio defines certain variables for you that are available without anything that you need to do manually. So these variables like default data path, default file prefix, and so on and so forth, they are available to you in the context of your deployment scripts. If you wanted, you could define new variables here, give them some default values and whatnot. So this is pretty handy. Build events. These are build events for the project. So what happens after the project builds, or what happens before the project builds. This is not the pre and post deployment SQL scripts. I will show you a little later within this demo how to make those pre and post deployment scripts. On the debug tab, basically what you should know about is the target connection string. So as you can see within this target connection string, my data source is defined as local DB project, and my initial catalog is My Adventure Works 2008 demo. So initial catalog is essentially the same name that I provided to the project in the beginning. But this local DB projects is essentially an extension to SQL Express, which allows you to run SQL Express without as an embedded database essentially. So all your SSDT projects will be deployed initially to your local DB, and you will be able to test those schemas and whatnot before you publish them to your production database. Also, what you will notice here is one important property, which is block incremental deployment if data loss might occur. So I usually always leave this checked. This makes sure that if I am creating any kind of deployment script that would drop a table or drop a column or something like that where data loss might occur, Visual Studio won't automatically deploy those and ask me to manually intervene. So this is kind of a safety net. On the code analysis tab, this is the static code analysis, such as style cop or FX cop and things like that work for other programming languages. But this is this code analysis is a set of rules for Transact SQL. So Microsoft has provided a pretty good starter set of rules that you should adhere to when you're developing your database schemas. If you want these rules to automatically run at every compile time, you can basically check this box and these rules will run automatically. I'm going to leave it unchecked because this is kind of a sample database, and I think that there would be some issues that I don't want to deal with during the course of this demo. So this is that. All right, so the next thing that we're going to do is add our solution to source control. Right click, add solution to source control, and that basically goes and adds the solution to the source control. after I've done that, I basically go in there and check in all my script files. So it's going to go and ask me for comments. Initial check-in, and I'm going to click on check-in. It's adding all my SQL scripts that we reverse engineered from our live database to our TFS source control. Once it's done that, you can see that all your items, show a little lock icon, which means that they're in the source control. So pretty simple. And then you get, the same check-in, check-out functionality, merging scripts and comparing scripts and whatnot. One more feature that I would like to show you here is that if I right-click on my project name, I can create snapshot project. So this is very, very neat. What this does, it created a snapshot. It's asking me to rename it. I'm going to leave the default name. So I'm going to click on enter. But what this does is creates a binary file. I can look at this file. It's a binary file. It's a point-in-time snapshot of my project. So essentially, I can go back to, or I can compare my schema against this point-in-time snapshot, or I can create, or I can compare a live database with this point-in-time snapshot, or compare two snapshots and find out what the differences are and things like that. So this is a very, very nice feature. All right, so the next thing that we're going to do is create a stored procedure. The process will be the same if you wanted to add new tables, add stored procedures, or any other schema objects. So I'm going to go and add a new folder called stored procedures, and then add a stored procedure to this folder. Add a stored procedure, and I'm going to call this USP get all products. So as you can see, it created a blank template of stored procedure. I'm going to remove these parameters, and here I'm going to experience the IntelliSense Nirvana. Select star from production dot product. Okay, so as you saw, it gives me real-time feedback. If I mistype fat finger an object name, it underlines it with squiggly marks and things like that. Also, a very very nice feature actually is refactoring. So I've written the stored procedure. I right-click on it, say refactor. I have several options. I can move from schema to schema. I can rename. I can expand the wildcards, use fully qualified names and whatnot. So, I'm going to show you expand wildcard. So right now our SQL statement shows select star from production.product. I'm going to right-click, say refactor, expand wildcards, and it's going to show me a preview of how my new SQL will look like. If I approve it, I'm going to click on apply, and there we go. So it refactored our SQL query. It's very, very nice. Also, this comes in really handy when we are moving an object from one schema to another, renaming a table, all those kinds of things. It will automatically go back and make modifications to all references to that name, to that object. Save this and close it. Okay, so now we're ready to build our solution for the first time. I can click on F6, or I can click on the build solution menu. And as you can see here, the solution just built. Everything was validated. Everything works good. Everything looks good. So it has basically just done a buffered build and validated everything. If I click on the start button, what it does is basically goes and builds everything plus deploys everything to my local DB instance. So here you can see that it's creating all these objects and whatnot. It shows that the deploy was successful. I can go to my SQL Object Explorer and expand on my local DB and make sure that my database was actually created by Visual Studio. So here, I can see all my tables. The new stored procedure that I created should be here as well. So USP get all products. That stored procedure made it to the local instance of SQL Server. Or actually local DB, I should say, because I'm also running another local instance of regular SQL Server 2008 on my machine. So there's a distinction between the two. So this kind of gives me a level of confidence that not only that my script's built locally, but also I can deploy it to a database instance, which is my local DB. But if I wanted to publish all my changes to an instance of SQL Server, all I really have to do is right click and say publish. And I can specify, which target database I want to publish my changes to. So I'm going to specify my local instance of AdventureWorks. That's basically the database that I reverse engineered my scripts from in the first place. So yeah, I can specify the any target connection string here. I can target multiple databases. So the good feature is that I can save the profile of this one, and I can save this as local AdventureWorks 2008. I can create another profile if I wanted to for a QA database or a production database and whatnot. It can either generate the script and show me the script, or it can publish the entire change set to the database. So I'm just going to click on the generate script for now, just to show you what the script looks like. So as you can see here, it's setting those database variable names that I showed you in the beginning, the properties of the project. It's setting those at the beginning of the script, and then it's going in there and it's essentially creating the stored procedure that we created. So that's the only change that we've made to the database schema. So that's all that it's doing for now. So that's pretty cool, and we're going to take a look at how it manages conflicts and things like that. For example, when we add a new column to a database table and all those kinds of things next. So next, what we're going to do is make a simple table change. So I'm going to go to my culture table and add a short name column to this table. So I can, actually I can add it here, or I can add it in the script. So I'm going to do it in the script. Short name, let's say 50 and null. So this is a nullable column that I'm adding to my database. I'm going to save this and close this window if I wanted to. Close this one also. And so now I'm going to say, okay, now what my published script looks like. So I'm going to try to do a publish here. Okay. And load my profile that I had saved before for my local AdventureWorks database and generate the script. As you know, when you're adding columns in the middle of a table within SQL Server, SQL Server doesn't really like that. So what it really does is, it essentially creates a whole script for what's known as create, copy, drop, rename or CCDR strategy. So essentially, it will go and delete all the constraints and all the foreign keys and things like that, make the change, do an alter table, and also then add all those constraints back. So this works really nicely when you're making a simple change, but just for that simple change you have to do a lot of stuff. So it's all generated code, it's pre-tested, everything should just work. I'm gonna do an actual publish to show you how this works. So we're gonna go and publish, load profile again, and actually publish my change to my local instance of SQL Server. So if I go back to my SQL Server, SQL Object Explorer, and refresh my database, so now I should be able to see my culture table here, production.culture. And as you can see, the short name has been added, right? So, and this is a nullable field. What if I want to add a non-nullable field? Well, so if I want to add a non-nullable field, I would have to specify some sort of a default value for it. So, if I don't specify a default value, then and add a non-nullable field, then Visual Studio cannot figure what I'm really trying to do. So, that will require some manual intervention. It would require me to create some pre-deployment and post-deployment scripts to copy data back and forth and fill that non-nullable field with whatever information that I need to. So we're going to go in here and take our culture table again. And this time we're going to add a non-nullable create date field. Created date. And we're going to call it, we're going to make it date time, and we're going to default this to the system date, and we're going to make this non-null. All right, so as we can see in the designer, our create date shows up. We're going to save this change. So first thing that we would like to do is to actually deploy it locally to make sure that it actually works. So I'm going to click on the start button. There were some deployment errors. I'm going to take a look, see what's that. Error list, get date is not recognized. Okay, so what I probably did, I provided, I probably fat fingered something. Yeah, so this is actually get date, not get date. All right, that looks good. So save it, and if I click on the start button, it should go and deploy my changes, and it shows deployment was succeeded. So now I'm confident that the change that I made here actually got deployed to my local DB instance. So as you saw, I fat fingered a default value, and Visual Studio caught it right away. I'm gonna go and now make this change to my SQL instance. I'm going to load the profile, and I'm going to do a publish. Okay. So what this will really do is actually go and make that change. If there was any data in that table, that data would be, it wouldn't change. So my deployment succeeded. I can go back, take a look at my, actually refresh this and then take a look at the table. And as you can see, I've added this get date field. So it's very nice, in a lot of situations, it saves us a lot of time and effort, which is what, which is basically any developers or DBA's dream come true. Okay, so now we're going to go and create some schema comparisons to see how things have changed since we checked in our product, checked in our solution. As you remember, the first time that I checked in my solution, I actually created a snapshot of my entire project. So I go here and right click and say schema compare. So the schema comparison screen essentially has two parts. One is the source and the other one's the target. So let's say that I want to find out that what's different between my source, which is the point in time snapshot, to my target, which is my current project. So I'm going to select a target and set it as my project. I can set my target to be any database, live database, for example, as well. So I'm going to click on compare, let Visual Studio do its magic. And as we can see here, that in order for me to update from my point in time snapshot to the current state of my project, I would have to delete a stored procedure, which is dbo.usp get all products, right? So because we created that stored procedure. Also, I would have to edit the table production culture. What I would have to do there is remove the create date and short name columns, because these are the two columns that we created. So let me show you what the script looks like. So not only that it tells me that that what is different, it also gives me a script to bring my schema to that version, or to the state of that snapshot. So here's what I've done. Here's what I'd have. Here's what the source looks like, and here's what the target looks like, right? So I would have to remove these two columns, which are highlighted for me, in order for my target to look like source. I can click on update, and it would ask me if I'm sure if I want to make these changes, and if as soon as I click on yes, it will go back and change my target schema to look like my source schema. So which is extremely nice. This is a huge time saver in a lot of time, in a lot of situations. So I strongly suggest that we create these snapshots whenever we feel that that we'll be making a lot of changes. We can create these snapshots, check them into source safe, source control. It's just a binary file, as I showed you before. It's not too big, and it could be a huge time saver in a lot of situations. All right, so the one last thing that I would like to show you is the pre and post deployment scripts. These are scripts that are run before or after the deployment scripts run. So what I'm going to do here is create a new folder to keep my scripts organized, and then create another folder called post deploy. Yep. And then add a post deploy script to it. So all I gotta do is pick the post deployment script from here. And so one limitation is that only one pre or post deploy script per project can execute. But that doesn't stop us from organizing our projects any way that we like, because we can include different scripts within within a post deployment script or a pre deployment script. So that's what I'm going to do here. I'm going to just add another script and call it culture.initial data .SQL, and I'm going to paste my insert statement. So this will actually insert one row into my culture table, and I'm going to copy this name here and here. In this post deployment script, I will have to use the SQL command mode and provide my script name. So that's essentially it. All, I can have as many scripts included here in the order that I would like them to execute after my deployment script has executed. So let's build this and give it a shot. As we can see here that the deployment was succeeded. So that's awesome. I'm going to publish this to local instance of SQL Server, and I'm going to load the profile that we had created earlier and publish. So it's going to take a little while to figure out what changes have happened, and sometimes it's a little bit slower, but usually it's pretty fast. So publish completed successfully. Now I'm going to go back to my SQL Explorer, go to my local SQL Server, and check out my databases. Go to my culture table, and it should have the row that we inserted in the post deployment script. So here, we see that row that we inserted in the post deployment script. So that's how pre and post deployment scripts work, and that's pretty much it. If you have any questions, feel free to shoot me an email. Thank you very much for watching, and I'll see you in the next demo.